So last time we learned about how to add polynomials. Today we're going to learn how to multiply polynomials. So let me start with, we're going to learn one major rule for this multiplying polynomials, but let's start with something really simple. You've seen this before. X cubed times x to the second power, x squared. How many, who knows? Okay, just raise your hand. Who knows what this becomes? All right, William. Oh, okay, Ryan? X to the fifth, isn't that right? Why? What does x to the third mean? Yes, Austin?
X to the third is like x times x times x.
That's right.
X second, x.
Exactly. So I wrote that down for you here. And of course you get x to the fifth, right? Because you're multiplying 5 x's all together. Yes, sir? Oh, yeah, let's just write multiplying monomials for now. Later we're going to actually multiply polynomials. You're right. By the way, what if I had x to like 300? Are you going to write 300 x's? No. Does anybody see a rule? Like any kind of rule when you have something like... Yeah, clear? You just add the exponent is correct, right? Does that make sense? So basically, all you have to do is, if I have a to the m to the nth power, this becomes, yes?
A to m plus n.
That's right. The exponent is going to be m plus n. Okay? Right? Any question there? That's the big rule we're going to learn today. Okay? This is the main thing. Okay? You need to know that if you have a to the m to the nth, or a to the m times a to the nth, right? You simply have to add the exponents. You don't have to write this out, right? If it's like a to the 300 power or 3000 power, you're not going to write. That's going to take you too long. You're not going to be able to finish your test, right? And you're not going to be accurate, when you write them out. Anyway, so what about this? Anybody know what to do for this? X to the third times y to the second. 1, 2, 3, 4 people think 5. Eric, what do you think? X, y to the fifth. How many people think it's x, y to the fifth? Raise your hand. No. You know why? I did this on purpose. Anybody see why that's not? Ryan? I'm sorry, Victor? Yeah. Look, in order to use this rule, people forget this fact that you must have same base. If you don't have same base, you can't just simply add the exponents. For example, here x to the third, y to the second, right? You don't get x, y to the fifth. You see what I mean? So you can't just blindly just use the rule. You have to know what this rule says. You must have same what? Base for this to work. If you don't have the same base, by the way, how do you then simplify this? X cubed times y to the second. Eddie?
X cubed plus x cubed y to the second.
Yeah, you leave it alone. You can't do anything. You can't simplify this any further. Does that make sense? Is that what you're saying? Yeah, you can't do anything there. You don't have same base. Okay? Does that make sense, guys? Do you see why that's important? Yes? Must have the same base. Okay? If it's not same, if the base are not same, you may not use this rule. This is the major rule we're going to learn. Okay? Any question? So if I have example 1, y to the fourth times y to the second. Now for this example, could we use the rule we just learned? By the way, there's a name for that rule. It's called products of powers, but I don't like the name, so I'm just gonna. Okay, anyway, so y to the fourth, y to the second. How about Kayleen? What do you think?
Y to the 6th.
Y to the sixth. You think it's y to the sixth?
Yeah.
Why?
Because it's y times y times y.
Yes, you could think of it that way, or you could use the rule. We just simply add the exponent. So do you think I want to see this rule right here? Okay, I want you to write that out, because guess what people do though? Instead of adding, sometimes people forget this and multiply. Do you think you're going to get the right answer? No. So what can you do to remember that you're supposed to add when you have this situation? So if you're like, you remember this rule but you kind of forgot whether to add or multiply, what can you do to kind of convince yourself, oh yeah, I'm supposed to add. What can you do if you're like, let's say you're taking a test and you forget, do I add it or multiply? What do you do? Yes, William?
Write it out.
Yeah, you can write it out, right? Just write it out. Y, just like Hayden said, you could write y times y, 4y's times, you have 2y's multiplying. You know you're going to get 6y's. So that's how you know you're supposed to add, not multiply. Because if you did multiply, you get y to the 8th, which is wrong. Does that make sense? So whenever you're taking a test, this is a nice hint or a good tip. Do a simple problem like this to convince yourself, right? Oh yeah, I'm supposed to add in this case. You know what I mean? Write it out. Does that make sense? Obviously, you don't want to do it for if it's y to the 400th power. That's too long. You just want to do simple ones. To make sure that you're supposed to add. Does that make sense? So this is a good example. Just convince yourself. Oh yeah, write it out. You're supposed to. You're gonna end up with 6y's all multiplying together. You see. All right. Let's look at example 2. This time it's not that different, except you now have some coefficients. Okay, everybody go ahead and try. See what you can do with this. What if I now have some coefficients? Okay, so notice, look at all the operations in between all the numbers and the variable. What sort of operations do we have? All multiplication is correct. Between 4 and n cubed, between, of course, these two monomials, and then 5 and n squared and so forth. So, I'm going to use, guess what property I'm going to use to simplify this? Since all the operation in between each numbers and variables are multiplication, yes? No, that's when you have an equation or something. I'm not solving for anything. How about Sarah? Yes, I would like to use the associative property of multiplication along with commutative property of multiplication too, because I want to rearrange them because I have some numbers, that I want to gather together to multiply. So first I separate everything because I know that's all multiplication. Then I rearrange them using this, right? I use the commutative property, right, of multiplication. Who thinks they know what to write next? How about Melissa? 20m to the 5th is the answer. Look at the kind of work I showed. I added together like that. Okay, so now if you're, the reason I did that is so that you don't make silly mistakes. That you remind yourself, oh yeah, I'm supposed to add. Because like I said, sometimes people like try to do this really fast and they just multiply or something. That'd be wrong. So write that out. Yes, question, Benjamin. Okay, good question. For the homework, if you're consistently doing this correctly every time, and you know how to do it right, okay, I don't mind you just kind of go, skip these steps. But if you're making mistakes, you know what to do. You know what I mean? I'm trying to help you guys here. Okay, so really showing this work step by step will help you. I'm telling you. Okay. Anyway, so yeah, on the homework, if you don't really want to do it and you're getting it right every time, you may just skip these steps. That's fine. Okay, let's look at example 3 now. But for now, I want you to kind of show the work for this example at least. Then, okay. So go ahead and show me the work that I want to see. Okay, go ahead and try example 3. It's a little bit different than example 2, but not that much, right? Everybody go ahead and try it for yourself. Okay. So anybody know what I did first? Okay, I separated everything first of all because all operations are multiplication. Kayleen, what did you write? Yeah, gather all the numbers, all the x's, and all the y's, right? So I separated all of them, indicating that they're all multiplication, and then of course gather them using the commutative property and associative property. Okay, who could tell me what to write next? What should I write next here? Viviana, can you help me? That's right. And even before that, I actually show my work by adding the exponents. So I wrote down 28x to the second plus 1. Where did I get this 1 from, by the way? And do you think that's a good idea? Yeah, that invisible 1. Do you think that's a good idea to write that 1? Because sometimes people don't see that invisible 1 as an exponent, and they don't add it. Does that make sense? So I think it's a good idea to write out, especially when you're gathering the exponents and so forth. Write it out. Okay, it just makes it easier. And of course, how many forgot the answer? Negative 28 a cubed y to the 9th? Good. Any question? If you didn't, do you see a mistake? Yeah, Sarah, do you have a question?
Oh, no.
Oh, okay, you got it? Do you got any question on that? Okay. Pretty straightforward. And as you will see tonight, homework is going to be very similar to this. They're going to get you, it's the same idea, everything, except now, look at example 4. It's going to be a little bit different, not too much. So example 4 is really similar, except now your coefficient is some fraction. That's the only difference. Everybody go ahead and try. See what you get. Give you time. How about, I want to call Vlad. What do you think I should do here, Vlad?
Use it to show the associative and commutative.
Yeah, use the associative and commutative property of addition, multiplication, to write this as
16 over 5 times 15 over 4, and then x to the second times x to the third, or x to the second plus third, and y times x times y to the second, or y 1 plus 2.
That's right. And look what I did here with the fractions. Could I cross cancel? Okay, one thing I wanted to, I don't know if I mentioned this. When you cross cancel, what does cross look like? What operation? Cross look like? Multiplication. So only time you can cross cancel is when you are multiplying two fractions, okay? So can I do this when I'm adding fractions? No. So think about that, okay? Remember, cross cancel means, cross, multiplication. Only time you can do this is when you're multiplying. So you're right, we get 12 times x times 2 plus 3 times y. Do you think it's a good idea to write 1 there? Yeah, just like Vlad said that already. What's the answer then, Vlad? Tell me the answer.
12x to the fifth, y to the third.
There you go. So only difference from other examples for this one was just coefficient this time was fraction. And it's not that difficult to deal with these. Any question? How many forgot 12x fifth, y third? Good? Are we okay? May I go on to the next example? Because this example 5 is where, and it's not too hard, but I put 2 stars on it. So let's see. There you go. Go ahead, try this one now, example 5. Now, before we begin, let me ask you, first of all, I put 2 stars on this. And there's a reason why. Any sort of difference between how is example 5 different than the other examples? Yes, Austin, you see a difference? There is an addition sign in the middle, and let's see how that may change. By the way, how many terms do I have in this example? Because in example 1 through 4, they were all monomials, if you look at it, right? How many terms do I have here? Tiani? 2. How many people say 2? Okay, anybody have a different answer? Does anybody say 4 terms? You're right, it's not. You didn't fall for it. We don't have 4 terms, do we? We only have 2 because terms are separated by which symbol? Addition symbol. And notice, this is a multiplication here, right? And so you have a really big monomial times plus another monomial. Does that make sense? Okay, go ahead, everybody try. Okay. If you need, let me just kind of begin. Is that okay? You can kind of follow along if you need the time. So I want you to pay attention for now because first of all, we're going to, the first monomial, we're going to gather all the numbers together and then all the variables together. We're going to rearrange them, right, using commutative property, same as the other. So I just separated them. And then did you all get this? 12, negative 12. A lot of people had really no problem getting it up to negative 12, a to the 5th, b to the 4th, plus 2, a to the 5th, b to the 4th, right? Is that okay? Now, should I leave it this way?
No.
Why not? Raise your hand. Why not? William?
Because the get only similar and you can combine them.
In other words, Shemin, what do we have here? They're like terms.
Yeah.
This is what we learned yesterday. You see how we're combining what we learned yesterday, right, with what we're learning today? So this is now a problem that we saw yesterday. What do we do next? We're going to use distributive property backwards, are we not? Okay, who could show me that? Who could tell me what to do next? Audrey, what should I write next? Using the distributive property backward, I could write